Okay, we're starting the recording now. No infantile shenanigans. Okay, first we're going to go over the quiz. I have never seen so many single digits in my life.
So, doesn't count.
Oh, it counts alright.
Oh, please.
It's part of learning. Language is the learning process.
Where's Gilson? So, what's the video? Let this be a lesson. If there's a quiz and you're kind of hazy about what it's on, even though we went over it the day before and I gave you the hint right before the quiz, then maybe we should come in the morning then. Because then I'll just put up, like I said, problems that are just like the quiz, but then don't we do it like the day before? Anyway, we have a quiz on Friday. How do I know there's a quiz on Friday?
I'm getting a brace.
My dad wants to
Oh, you went to get your book? Oh, you don't need books. No, you're not going to put it back. Strike one! Okay, who's supposed to be sitting here? Oh yeah, Tara Mai. What did you get, Kevin? Oh, Suzuki.
20.
That was pretty good.
18. 17.
Let's just start with the one.
Okay, so since we're recording, I only can write on this 2/3 of the board because that's all the camera can get. Okay, I'm gonna go over every single problem because, hey, get up. Make the corrections because 2 of these problems are gonna be on Friday's quiz. Because it's not good enough to quiz and then we get low scores. I'm gonna have to quiz again and again until we get it. Okay, so this is the appetizer. This is the easy one. Now, people, I wrote the 4 steps down over here. X-intercept, Y-intercept, vertical asymptote, horizontal asymptote. Do these 4 things on every one. You might just get 1 point. Okay, x-intercept. When is the top 0? 1/2. Y-intercept. Plug in 0 for x. You know what? I'm kind of shocked because a lot of people, we have a problem plugging in 0 for x. If you plug in 0 for x there and there, you can get -1/2. What is that? -1/2. Vertical asymptote is when the denominator is 0. X equal -2. You're lucky I'm not making you label it. You just have to draw it in. Now the horizontal asymptote, if the degree of the top and the bottom are the same, you look at the leading coefficients, 2/1. So it's y equal 2. So how do I know the graph is up here like that? Because if you drew it down here, it would touch the x-axis. You are like touching the x-axis and there's no x-intercept there. You only can touch the x-axis when there's an intercept. And since it's exploding up on this side, how do I know it's exploding down on this side? Because there's an odd power. In the denominator, if there's an odd power, it goes opposite way on the asymptote. The denominator tells you things about the asymptotes. The numerator tells you things about the x-intercepts. So, and of course, some of you are plotting points and your graph doesn't even go through them. I had several people, they get 2 points like this and they draw the graph like this. I don't want to mention any names. Okay, look at your papers. That you. If you have points, the graph gotta go through the points. Like that. And some people, look, rational functions. Whenever you have a horizontal asymptote, what happens out here? The graph gotta get closer without touching. Because some of you get the horizontal asymptote in, and then you're going farther away. You gotta get closer to it like that. That's what the horizontal asymptote is there for. Yeah.
How do you know if it's like this or like that?
Odd power. So if it explodes up on this side, it's going to explode down on that side. Okay, look, here's a vertical asymptote. if there's an odd power, if this one goes up, then the other side goes down.
Okay, and if it's even.
No, silence. If it goes down on this side, then it goes up on that side.
Okay.
Okay, now, if you have an even power, if it goes up on this side, going up on that side.
How do you know it starts up on that side?
Silent. And then if it goes down that way, it goes down on that. You gotta wait till it's done.
Oh, sorry.
That's because we knew the thing goes up there, that's why.
How do we know?
Because if it went down there, it would touch the x-axis, but there's no x-intercept there.
Oh.
So the graph cannot cross the x-axis here, therefore it has to be up there. Anyway, like I told you when we did the homework, what if you don't know anything? Plot a point. In fact, I gave you so much time on this quiz, you could have just plotted points. So plug in a number like to the left of -2, what would that be? I mean, hopefully you don't have to do this, but if you have to. If you plug in -3, what is -6 minus 1? And what is -3 plus 1? I mean 2. -1, so isn't that 7? So -3, comma 7 is a point on the graph, so that's why it's gotta be up there, right? But you don't plot points unless you absolutely have to. But like I said, if I gave you the amount of time I gave you for the last quiz, oh boy. Some of you are plotting 3 out of the 4, but you don't do the 4th one. It's kind of strange. Hey, don't laugh. X squared minus 4, x squared minus 1. Okay, now if you have to, because some of you only have like part of the x-intercept, if you have to completely factor it like this to see everything, then do it like that. What are the x-intercepts? What makes the top 0? -2 and 2. Y-intercept, plug in 0 for x. I think it's easier to plug in 0 for x in this one. If you plug in 0 here and here, you get -4 over -1, which is 4. Vertical asymptote is when the denominator is 0. What makes the denominator 0? Who was it? Who was it? When I was grading the quiz, it says horizontal asymptote. What did they just write? You write -1. Or they just wrote 1. Or whatever. No, it's x equal 1, or if it's y equal 1. You can't just write 1. Oh, so got me? See, I just remembered, popped into my head. Okay, horizontal asymptote. If the power on the top and the bottom are the same, you look at the coefficient, so what is that? Y equal 1, not 1, y equal 1. Okay, now kugia, is the graph up here, or is it down there?
Down.
Okay, how come?
Because there's an x-intercept.
Yeah, because you gotta hit that point, so it's gotta be down here. And please, don't do this, some people doing this. Whoa, this is fun. Well, first of all, it's getting farther from the asymptote. And anyway, if you draw it like that, that's not even a function. It doesn't even pass the vertical line test. I thought it was April Fool's when I was looking at the graph. Like this. Okay, now look, it's exploding down on this side. How do I know it's gonna explode up on the other side? Because what is this vertical asymptote? X equal -1. It came from this factor, odd power. So that's why it explodes on the. Anyway, if you think about it, look, you have 2 vertical asymptotes. Okay, look, when you have 2 vertical asymptotes, there's only 4 ways the graph goes. It's either u up, u down, or slide up. That's the only thing it can do. How do I know in this case it has to be u up? Well, first of all, it's got to pass through that point. How come it just can't slide down then, Mr. Park? Because there's no x-intercept there. The graph doesn't cross the x-axis. Somebody actually did this. They did this. They went like this. They had the point, and they went like this. And then they make the arrow like that. Like that. See, Mr. Park, I didn't touch the x-axis. Yeah, but the arrows mean it keeps on going. You know what I'm talking about? So it has to go up. Because you cannot touch the x-axis, that's why. You only can touch the x-axis when there's an x-intercept. Okay, now, what about on this side? Is it up there or down there? Yeah, how do I know it's down here? Well, first of all, you got to pass through this point. Secondly, if it explodes up on this side, you got to explode down on that side because x equal 1 came from this factor, odd power. Now, powers tell you everything. Okay, next one, number 3. And hopefully we can, our goal today is to finish by 2:45. That's our goal. y equal x minus 1 over x squared plus 1. Okay, go through the four things. X-intercept, look at the top. Y-intercept, plug in 0 for x. Negative 1. Vertical asymptote, what makes the denominator 0? This is where some of you just went crazy. Some of you put I, some of you put plus 0. Yo, well, I does make the denominator 0, but what happens when you get imaginary things? You ignore it. There is no vertical asymptote. You cannot graph imaginary things in the Cartesian plane. Okay, horizontal asymptote. If the degree of the bottom is bigger than the top, then it's y equals 0. Okay, now I know the graph got to go through these 2 points. Okay, now, do I go through this point or bounce off? What should I do? How do I know I go through? Because x equal 1 came from this factor, it has an odd power. The numerator tells you what happens on the x-intercept. Either go through or bounce off. Now what? I don't know what to do, Mr. Park. If you have a horizontal asymptote, which all of these graphs do, then as the graph goes out to the right, you got to get closer. As the graph goes out to the left, it's got to get closer. Some of you are drawing the graph like this. I don't know, I think you just got to go down here. No! Do you guys understand that? As the graph goes out to the left and the right, it gets closer to whatever your horizontal asymptote is. Okay, number 4. Y equal x squared minus x minus 6 all over x squared minus 4. The first thing you should do is factor it. Why do you factor it? Because this cancels. Ooh, what happens when you cancel factors? You're going to have the removable discontinuity, the puka. So all you do is you graph this, and when you finish graphing, then you put the puka in. Okay, so you look at this graph, go through the 4 steps. X-intercept. What makes the top 0? Y-intercept. Plug in 0 for x. 3 halves, 1.5. Vertical asymptote is when the denominator is 0. X equal 2. And horizontal asymptote. If the power on the top and the bottom are the same, you look at the coefficients. Y equal 1. So what do you think? Is it up here or down there? It's got to be up here. Why? Because it can't be down there, otherwise it would cross the x-axis and there's no x-intercept there. And then if it's up there, how do I know it's down here like this? How do I know that? Well, 2 reasons. 1, you got to pass through the point. Secondly, there's an odd power in the denominator, means it's going to go opposite way. See, there's so many clues. This is like a mystery novel. You put the clues together and you just figure it out. It's like a puzzle. And then, since I crossed out x plus 2, there's going to be a removable discontinuity at x equal negative 2. What do you mean you parentheses the wrong one?
Put that odd power on the 2, but I don't know, it doesn't matter, but it came from the 3 on the top.
Okay, can you speak English now?
Like, you know how you said it crossed through because it has an odd power?
Yeah.
It crossed through because it has an odd power on the...
Yeah, when you have, when in the top, if you have an odd power, that means at the x-intercept, it goes through the x-intercept. If you had an even power on that, then it would bounce off the x-intercept. But then, that's the next problem. See how both of them get even powers? Okay, last one, then we can start class. Okay, 4 steps. X-intercept. 1, Y-intercept. Some people have trouble plugging in 0. Do it very carefully because you know what? If you plot the wrong Y-intercept, and then, is this you on yesterday's quiz? Hey, this graph is not making sense. Yeah, that's because you plotted your Y-intercept wrong, probably. Plug in 0 for x. What is 0 minus 1 squared?
1.
What is 0 plus 1 squared? 1. What's 1 divided by 1?
1.
Wait, can we use calculator? 1. No, you can't use a calculator. Vertical asymptote. When is the denominator 0? Horizontal. Now, if you multiply out the top, you don't have, like, some of you can just see it already, right? If you multiply out the bottom, what's the horizontal asymptote gonna be? Y equal 1. Because when the degree is the same, you look at the coefficients. Mr. Park, I see a point on that horizontal asymptote. Is that gonna bother you? We talked about this already. No! Because horizontal asymptotes only take effect out here. Okay, now on this side, what do you think it is? Up there or down there? It has to be up here because there's no x-intercept here. It's gotta be up there. Now, since the thing is exploding up on this side, doesn't it have to explode up on this side? Why? Why does it have to go both the same? Because x equal -1 came from this factor, even power. So that means when you have the vertical asymptote, they go the same way. Anyway, think about it. Even if you did do the wrong thing, even if you did do it over here, how the heck can I get to that point without touching the x-axis? Right? How can you go like this and I gotta hit that point and then I kind of touch the x-axis? So go all the way around. No, that's not even a function. Just like April Fools. So it's got to be up here. See, all the clues all make sense. Okay, now I'm coming up to this x-intercept. What do? Do I go through it or bounce off? You bounce off. How come I don't go through, Mr. Park? Because when x equals 1, that came from this factor, even power, bounce off. Anyway, if you don't bounce off, how in the world are you going to get closer to the horizontal asymptote? Because if you come down, how are you going to get closer to that without crossing the x-axis? See, that's why if you do the 4 steps and you do it correctly, the graph just makes sense. Because otherwise you can't do things. You know what I'm talking about? Okay, so tomorrow I'm going to have 2 of these. Okay, we're going to do the review anyway. Okay, today's lesson. If you get confused, watch the video again. Oh, look at that. It's beautiful. Wow.
What video?
No, in the video.
We're videotaping this?
I quit.
Where do you?
Wow. It looks looks nicer on video than actually live. Put your hand up. Whatever. Okay, now, well, I guess if some people don't even know we're videoing, does everybody understand that tonight's homework 5.5 is not in the book? It's on a worksheet that's on the site. So you have to go to the site and download it. It says right there, it says synthetic division worksheet. What's that, Mr. Park?
So we don't need our textbooks for the time.
No, in fact, you don't need it already because this is the last thing we're learning. I'm going to give you a practice test, and the test is on Tuesday, right?
We don't need it anymore.
For this chapter. Don't throw it away. Are you thinking of throwing it away?
I just kind of bust up.
Okay, now we know how to solve quadratic equations, right? Like if I give you a quadratic equation, x squared minus 2x minus 15 equals 0. Do we know how to solve that?
Yeah. X
Either
minus
you-
5.
Well, first of all, you make one side 0, right? Then you either factor it or use the quadratic formula, right? But what happens when it's a third power or higher? Like this. What if you have this? X cubed, I'm trying to concentrate. Plus 11x equals 6x squared plus 6.
Oh, that's easy.
Now what
Synthetic
kind,
division.
is this a quadratic equation?
No.
No, this is a cubic equation. The highest power is 3. You never learned how to solve cubic equations. Okay, but I'm going to teach you now. But I'm going to simplify it for you. First step, make one side 0. Anytime that the power is 2 or bigger, you always make one side 0. You don't even think. Okay, now you've never seen this before, so you guys need to take notes or at least read the book or something. Oh gosh. Okay, now watch what Mr. Park, now did you guys learn factor by grouping in Algebra 1? 1B, 1C?
Yes.
Does that sound familiar? Factor by grouping, but that's hard, yeah? Because you can actually factor this by grouping. But a lot of people have trouble with that, so that's why somebody invented this thing called synthetic division, so that you don't have to factor by grouping. So watch what I'm going to do. The first thing you do is you write down the coefficients of this polynomial. 1, -6, 11, -6, like that. You write down the coefficients. Now if 1 is missing, you have to put a 0. Like if there's no x squared term, then you have to put a 0 here. Okay? Then you put a box like this, and then you draw a line under it like that. Now I'm going to teach you synthetic division. Now synthetic division is a guess and check process, okay? So what you do is, we're going to put numbers in this box, and we're going to do synthetic division, and our goal is to make this number over here come out to 0. Okay? If it doesn't come out to 0, then we've got to do it all over again. Okay? So, let's start with 1. You should always start with 1. Okay? Actually, there's a theorem that tells you what numbers you should try, but I'm simplifying it for you. In this class, the only numbers that you're going to try in this box are either 1, 2, -1, or -2, and that's it. Yeah, you don't have to try fractions or big numbers like that. Yeah. No, you don't have to try 0. No, because, okay, no, there's no 0. Just watch, okay, see. Now, what is synthetic division, Mr. Park? Well, you see this first number over here? You just drop it down. This first number gets dropped down. And then all you have to do now is multiply and add. Multiply this times the number in the box.
1.
Write it there. Now add these numbers. -5. Okay, now multiply this number times the number in the box.
-5.
-5. Add.
6.
Multiply that by the number in the box.
Oh, you get 0.
Can we wait till we get there? 6. Add.
0.
0. Now, if this number is not 0, then what you got to do is pick a different number in the box and do it all over again.
Wait.
So your goal is to get, this is called the remainder. Okay? We want the remainder to be 0. If it's not 0, pick another number, do it all over again. McKenna had a question.
How do you even, what is that going to do?
Well, I'm going to show you. So, when you see a 0 here, in the box here, in this end box, that's a remainder. You're happy, because that means that x minus the number in the box is one of the factors of this. You get it? So if you do synthetic division by a number, and the remainder comes out 0, that means x minus the number in this box here is one of the factors of this.
So if it's -1, it'll be plus.
Yeah,
x
so
plus
if
1?
if it were -1, then it would be x minus -1, which would be x plus 1. Yeah. You guys get it? Okay, now, yo, Mr. Park, what's the other factor? Well, you just look at these. These are called the depressed coefficients. You don't have to know the name. You can just call them the coefficients. But these numbers stand for this factor. This gives you the coefficients of this factor. What do you think that's going to be?
X squared.
X squared minus 5x plus 6. That's what that stands for. But that only works if the remainder comes out 0. Okay, so that is the same thing as this, except we factored it. And then, once you get it down to a quadratic over here, you either factor it some more or use the quadratic formula, right? Yeah.
Wait, so how did you get x minus 1?
Because the number in the box, if the number in the box is 1, and this number comes out to 0, then x minus this number is one of the factors. Okay, now, is this factorable or do I have to use the quadratic
Factorable.
formula?
X minus 3 times x.
Okay, it's factorable, so this is equal to x minus 3 times x minus 2. Did I do that correct?
Yeah.
Yeah, and now that it's all factored, equals 0, isn't this problem easy now?
Do you have to plug it back into the equation?
No. If somebody gives you this times this equals 0, doesn't that mean either this is 0, or this is 0? So what are my answers to this equation? 1, 3, and 2. Box that, that's the answer. See, when you do a quadratic equation like this, you only get 2 answers, but now you have a cubic equation, you get 3 answers. Oh, what if you had a quartic equation?
4.
You would have 4 answers, that's right. In fact, a polynomial of degree 5 will have 5 roots. This is a polynomial. You guys know what a polynomial is, right? It's anytime you have x to whole number powers. Okay, let's do another example. I had a good example too. Here, I was going to actually write notes for you, but I changed my mind. Oh, here it is. Here's a good example. So tonight's homework, you only have 7 problems. My dog can do 7 problems.
Are they hard problems though?
No, they're not. If you just listen to what I'm saying, it's easy. Okay, solve for x. Solve for x. Woo! X cubed plus 30 is equal to 4x squared plus 11x. Okay, what's the first thing I should do?
Make one side 0.
Make one side 0 and put it in order. Make the first term positive also now. You don't have to, but it's just a lot easier when it is. So x cubed plus 4x squared minus 11x plus 30 equals 0. So what kind of equation is this? It's a cubic equation. Anytime the power is 3 or bigger, that's when you're going to do synthetic division. So how do I start it again? You write the coefficients. What are the coefficients? 1, negative 4, negative 11, 30. You put a box here, and then you put a line. Okay, now, Mr. Park, what do I put in the box? Well, I told you in this class, I'm going to make it easy for you. It's either plus or minus 1 or plus or minus 2. Because when you do this in pre-calculus next year, there's a theorem that tells you what numbers to try in the box, okay? But I'm not going to complicate it for you here, okay? If you don't hit it, if you do plus or minus 1 or plus or minus 2, then you did something wrong. Okay, so what's the first number I should try? Yeah, I think you should start with 1. Okay, so how do you do synthetic division?
Drop it.
You drop this first number down. Then all you have to do is multiply and add. Multiply this times this.
1.
Put it there. Now add. It's just a technique. It's quite easy. Multiply that times the number in the box. Write it there. Add. Okay, if we cannot add, then just go home, cook rice already. Multiply that times that. Add. That's 16. Is that number 0?
No.
No, so
Try 2.
yeah, so that means start all over. Now you probably don't want to erase yet, just leave it on your paper, just go down a little bit more. Okay, so which one do you want to try? 2 or negative 1?
2.
Okay, let's try 2. Okay, so drop the 1, multiply 1 times 2. Add. Add. Multiply that times the number in the box. Negative 4. Add.
15.
Oh.
People, I can add. If you guys cannot add and multiply, like I said, just go home, cook rice. In fact, don't even wash the rice. Multiply this times the number in the box. Negative 30. Add. Woohoo! And that's what you want. You want that remainder to be 0. Okay, so what does that mean if the remainder is 0, Mr. Park? That means x minus the number in the box is one of the factors of this. Because there should be 3 factors, right? And what's the other factor here?
X squared.
Yeah, you look at these depressed coefficients. This stands for x squared minus 2x minus 15. X squared minus 2x minus 15. And once you get it down to that second power there, you either factor it some more or use the quadratic formula. I think only one problem tonight I made you do the quadratic formula. Come on, stop whining. So how do I factor this one?
Minus 5 plus
X minus 5, x plus 3. Is that correct?
Yeah.
Of course, I'm the teacher. So tell me, what are my 3 answers?
2.
X equals 2, x equals 5, or x equal negative 3. Box that as the answer. And this is how you solve equations when the power is 3 or bigger. Yeah, but now of course, I'm sure you have this question. Mr. Park, what if I try all the numbers in the box and none of them work?
No, no.
And it's
Can you
not-
still solve it? Yes, but then
It's not accurate.
you use your graphing calculator.
Use the theorem.
Yeah, but even if you use the theorem that you're going to learn there, sometimes none of them work. In that case, then you pull out your graphing calculator. So what you do,
We start
and
with
it makes sense, you graph this on your calculator. See, if you graph this on your calculator, it's going to look like this, right? Cubic polynomial, leading coefficient positive.
Oh, just find the points and crosses?
Exactly, and here are your 3 answers.
Did we just do that in the beginning?
No, because we're not using graphing calculator. Next year in pre-calculus, you will be. You're going to learn how to calculate these 3 x-intercepts. All you gotta do is press a few buttons on your calculator and I think it spits it out. How many of you, does anybody have a graphing calculator right now? What kind? 84, 83, 89, 92? Huh? 84? Does anybody have an 89? No, because if you have a TI 89, you don't even have to draw the graph. You just punch this equation in and thing spits out the answers. It's a very powerful calculator. 89. But don't just go out and buy it now. No, because it's more difficult. It's high powered, but it's more difficult to use. How many of you taking pre-calculus next year?
Don't you have to?
Yeah, the graphic calculator is required. Okay, so do you think you can follow this to do tonight's homework?
Yeah,
Or do we need one more example?
we're good.
No, I understand. I
we're good.
understand.
Yeah.
Is there anything that's different than that? Or is it basically the same?
No, it's basically the same. Okay, no, I'll give you a little different one. A little bit different. Little. Okay, see, this is. Never mind. I just do this out there. Solve for x. X cubed. I hope this is not the same as the homework. I don't want to make it the same as the homework. No, it's not. It's less than or equal to 3x minus 2. Okay, do we know how to solve inequalities? Yes, that's on Friday's quiz. No! The only difference is instead of equal, it's less than or equal to, right? Do we know how to solve inequalities?
Make it
Make
0.
one side zero.
Yeah, okay, make one side 0. You always make one side 0.
Factor.
Okay, and then once you make one side 0, you gotta factor this. Yeah, but Mr. Park, this is third power. That's when you do synthetic division. So you put the coefficients 1. Okay, yeah, but Mr. Park, there's no x squared. That's when you put the 0. You have to put the 0 there now. What happens if you don't? No, yeah, pain. That's what's gonna happen. Pain. Okay, so what number should I try in the box?
1.
Yeah, start with 1, then go to 2, and if those don't work, then go to -1 and -2. Okay, so 1. Drop the 1 down. Okay, you guys fill in the numbers. Go. Multiply that times the number in the box.
0.
No, 1.
It works.
1 times 1
Zero.
is 1. If you cannot multiply single-digit numbers, just go home. Don't even cook rice. Just go home. That
It
add.
works.
0. It
It
works.
works.
Okay, can you please wait till we get there? Multiply that times the number in the box. Add. No, I can do this all day long. I can do this in my sleep. You guys gotta do this when you're awake. -2. Oh, 0, yeah! Hooray! So what does that mean? That means x minus the number in the box is a factor. What's the other factor? You look at these. What does that stand for?
X minus.
X squared plus x minus 2 equals 0. See? If that's, or whatever. Okay, let's just keep going. X minus 1. And can this be factored or do I have to use quadratic?
Factor.
It factors, buddy. X plus 2, x minus 1. Oh, this is not equal to 0, fool. It's less than or equal to 0. So, Mr. Park, if I get 2 x minus 1s, should I write it as x minus 1 squared? You bet your bippy you should. Okay, so Mr. Park, can I just write x equal 1 and x equal -2? That's the answers. No, this is an inequality. This is on Friday's quiz. How do you solve inequalities once you make one side 0 and you factor this side? You make a number line. You guys just did it. Remember the homework was so easy, you were telling me?
It wasn't. That's what you
Okay, what numbers do I put on this number line?
1 and -2.
1 and -2. And please, don't do this. Every year there's always a couple clowns that do this. Hello, 1 is bigger than -2. No, you guys laugh now, but you guys can do this Friday. Are these points, why are these points part of the solution?
Because
Because
it's
less
equal
than or
to.
Because, or, okay, very good, or equal to. Okay, now, you have 3 regions to test. You can start anywhere, but what's the bestest one I told you? The one over here. So if you think of a number bigger than 1, like 2, 2 minus 1 is positive. 2 plus 2 is positive. Positive times positive is positive. This one's always going to be positive unless it's not. Like if there's a negative side, but I don't think I'm gonna give you that, right? Okay, now you wanna use the shortcut or you just wanna just plug in numbers? Okay, the shortcut, 1 came from this factor, which has an even power, so stay the same. Yeah, the graph bounces on, that's why it stays the same. Negative 2 came from this factor, it has an odd power, so what?
So.
It changes. You guys remember that shortcut or is that gone from the memory already?
So X.
Okay, now we're looking for less than or equal to 0, so we shade in the -1, and that's your answer. Now how do you write this answer? X is less than or equal to -2, or X equal 1. Don't forget this point now. Every year, students, they forget this point there. That's only -1, that's okay. 19 out of 20 is a darn good score. Or would you rather write -infinity to -2, including it, and then 1 to 1?
Wait, how is it X equals 1?
Because that point is part of the solution.
Oh, yeah.
Because if you plug in 1, you get 0, right? Isn't 0 less than or equal to 0?
Yeah.
Let me think about that. Yes. I really did think. Okay, so you do the exact same thing. The only thing different when you have an inequality is you make a number line. That's the only thing different. And then the other thing different on that is, okay, what if you had this? What if you had to graph y equal this? Because someone get two problems where you have to graph y equal. What would you do? You do synthetic division to factor it like this. Because once you have it factored like this, what do?
Oh! Put it at the 1 and then bounce
How do
off.
you, yeah, how do you graph polynomial functions? First you graph the x and the y intercepts. What's the x-intercept?
1.
And,
-2.
so you go 1 and -2. What is the y-intercept? If I plug in 0 for x, it's easier to plug in 0 for x in this one. 2. What is the degree of this polynomial? 3. The leading coefficient is positive, so isn't the graph like this? So, okay, I'm going. Where do I go? Go through or bounce off? You go through because -2 came from here, odd power. Okay, now I'm coming up to this x-intercept. What? It has an even power, so you bounce off. Woo! And that's what the graph looks like. So it doesn't matter what you do, you still have to do synthetic division to factor it. You guys know what I'm talking about? So what is synthetic division? What do we use it for? To factor when the power is bigger than 2. Okay, oh, we're ahead of schedule, people. Okay, here's the quiz on Friday. Stop looking at it. How dare you?
Is that quiz gonna replace astronomy?
No, Jace. It's in our grade already.
Okay, that's it. We're going home at 3:15 just for that. Okay, so we do this every single time, people, before a quiz. Ifuku. By the way, Ifuku, are you related to Christine?
Oh yeah, she is.
Christina.
Ifuku!
Oh, no.
She's related to Holly.
Oh, yeah.
Okay, I don't know how to
No, Holly.
Holly
Chong.
Chung.
Whatever! I don't know what you guys are talking about. No, okay. Okay, look. See, this is what I do when I don't know why I'm admitting it on camera, but I will. Okay? Every time we take a quiz,
Wait,
so
look at the camera.
I hold the quiz in my hand. I don't know what more I can do, and I look at it and I make one almost exactly like it with different numbers to help you. Okay, now I'll pay attention to the part. No, what does? Yes. What? That, oh, to solve for x. It says solve the following inequality. So there's only 4 problems on this quiz. 2 of them you're doing inequalities, and 2 of them you're gonna graph because we did so bad on the last one. Okay, I'm gonna pick one to put the power on. Which one?
One.
This one? Okay, put the 2 there then. Okay, here we go.
But you have to put a power on one of them.
I'm gonna put powers. I'm testing to see if you know what happens when you have odd and even powers, right? Okay, first thing you do is make one side 0, and the other side is factored. It is already, Mr. Park. See, it's gift wrapped for you. That's what I was talking about. So, you're ready for the number line already. What goes on this number line?
-3, -1, and 2.
Okay. Are these 3 points part of the solution or not part of the solution?
Not part of this.
Okay, very good. How do you know?
Because it's not.
Yeah, because there's no or equal to there. Okay, now there are 4 regions. Why do I like this one? Because it's going to be positive. And just to make sure, if I plug in a number bigger than 2, like 3, 3 plus 3 is positive. 3 plus 1 squared is positive. 3 minus 2 is positive. Positive times positive times positive is positive. Now, do you guys understand why this one's always positive? Because all the numbers are positive. When you I can multiply 100 positive numbers, it's going to be positive. Okay, you want to use the shortcut or just plug in numbers?
Shortcut.
Okay, 2 came from here. It has an odd power.
Change.
Negative 1 came from there. It has an even power.
Same.
So stay the same. That's not the same form. Negative 3 came from there, which has an odd power. Change. And then we're looking for greater than 0, so we shade in the ones with the pluses. If it said less than 0, you shade in the ones with the minus. Now you look at your number line and you just write your answer down. X is less than negative 3, or x is greater than 2. Or do you write negative infinity to negative 3, union 2 to infinity? I don't care. Write 8 to 1. Okay, next one. Don't look! I see you looking. X plus 2, x minus 4, all over x minus 5. Let's go greater than or equal to 0. Okay, put an even power on one of these. Which one? Top, bottom, which one? The bottom. Okay. Okay. Okay, so can I just make the number line now, or do I have to do work? Like, remember the one on the homework? We had to do plenty work? No! One side is 0 and everything is factored. It's gift wrapped already. So you make the number line. What goes on this number line? In order, please. Negative 2. What makes either the top or the bottom 0? 4 and 5.
Wait. What? Oh, that's a that's a 4, not a 9.
Are you criticizing my writing? That's the second meanest thing anybody ever said to me.
What's the first?
I do.
Oh yeah. He said it on camera.
I'm sorry, honey. It's just a joke. Please. Why would my wife watch this anyway? She's not going to watch this. Anyway, is negative 2 part of the solution?
Yes.
Yes. What about 4?
Yes.
Yes. What about 5? No, because it's in the denominator. Anytime the denominator is 0, it's undefined. No can be. See, these little things, each one could be like -1. See, it's easy, but you can get -1s here and there, yeah? Okay, how do I know without even thinking this one's plus? Because positive, positive, positive squared, right? Everything's positive. Okay, now look, 5 came from this factor. It has an even power, so stay the same. 4 came from this factor. It has an odd power. Change. Negative 2 came from this factor. It has an odd power. Change. And we're looking for greater than or equal to.
Why is that plus?
Change, I said. I said change. Okay, we're looking for greater than or equal to 0. So we shade in the pluses. And then we simply write down our answer. Okay, I'll write this. X, double. X is less than or equal to -2, or 4 is less than or equal to x is less than 5, or x is greater than 5. Or would you rather see negative infinity to -2, bracket, union, bracket 4, comma 5, union, parentheses, 5, comma, infinity. I like both of them. They both look nice.
No.
Question? Pas question? Il y a beaucoup pas fait? Minimum culture do something. C'était plein moment. Dans 5 minutes.
What?
I don't know, I just remember that from my high school French class. I don't even know what it means. What did I even say?
I heard that.
What did I say?
Is it,
No, what were we talking about?
I thought you were asking.
Minimum culture sur la fin.
oh!
Mais nous. Wait. Now you got me thinking. Mais nous
Wait, who speaks
manquons.
French?
Mais nous manquons.
Nobody.
Nous manquons toujours la fin. But we eat. Wait, mais nous manquons toujours, always, le pain, hungry.
We eat because we're always hungry.
But we eat, yeah, or something like that. Whatever. Why am I even talking about that? That's French. Wait, what did you think it was? Okay, and then the last two problems are graphs. Okay, let's just do these two graphs and you can go home. Y equal, okay, I'm going to test to see if you, again, even and odd powers, those are the things. X plus 2, x minus 3. Okay, let's do that one first. Graph this. Okay, what do you do when you graph these rational functions? You go through the 4 steps that I taught you. Okay, if you have to write it, I'm not going to write them down like I did on yesterday. Now. You better write this down on your paper yourself. X-intercept, y-intercept, vertical asymptote, horizontal asymptote. These are the 4 steps you go through. Okay, x-intercept, what do you do?
0.
When is the top 0? Look at the top. When is it 0?
0.
Now again, if the x-intercept is 0, does that mean the y-intercept is 0?
Yes.
Yes! Vertical asymptote is when the bottom is 0. What makes the bottom 0? Okay, so x equal -2, x equal 3. Horizontal asymptote. If the power on the, now look, if you multiply out the bottom, what is that going to be? It's going to be x squared minus x minus 6, right? If the power on the top and the bottom are the same, you look at the coefficients. Who said 1? It's 3. 3 over 1. Y equals 3. It's like this. Okay, now we are ready to graph. So is it up here or down there? Why does it have to be up here?
Because you gotta go
Yeah.
down on the.
Well, that's because there's no x-intercept here. Right? How are you gonna make it go down if there's no x-intercept? Now, if this thing is exploding up on this side, what? On the opposite side, is it up here or is it down here?
Down.
How do I know? Yeah, because -2 came, the vertical asymptote of -2 came from this factor, odd power. So it's gonna go opposite way. Okay, now, I'm coming up to this, what do? Go up
Bounce
through it
off.
or bounce off?
Bounce off.
You bounce off, how come?
You can't go anywhere.
No! What do you mean it can't go anywhere? I could have gone through and go up like that.
There's no.
See, yeah, that's right, you don't know.
Even power.
It bounces off because 0 came from here, it has an even power, that's why it bounces off. And then now what? You gotta go get closer to the asymptote now. And then, since the thing is going down this way, on the opposite side, is it down here or up here?
Up here.
It's up here because x equals 3 came from this, which has an odd power, so that's why it goes opposite way. And then, I'm not sure what to do, Mr. Park. When the graph goes out to the left and the right, you gotta get closer to that horizontal asymptote. Are we getting it now? See, so maybe you don't have to come in tomorrow. Because, okay, when you come in, all I'm gonna do is I'm gonna look at the quiz, I'm just gonna put 4 problems that are just like the quiz on the board. Maybe, I don't know. You can still come in for extra practice, right? What's wrong with getting like a 20 out of 20? Nothing wrong with that. Oh, you got it on camera.
Oh, no, you're.
Oh,
you're like
this was
walking
on the
drop.
camera, so you can zoom in. You guys are dirty. Is that the way you guys think? Can you zoom in on YouTube? Because it's on YouTube.
No.
Can I zoom in?
No.
See? There, you cannot zoom in.
Screenshot and
Pause it. Go try. Pause it and then what?
Take a picture.
take a picture.
take a picture on YouTube. If the thing is grainy, you can zoom in, you're not gonna see anything anyway. What are you guys, I don't know what you guys are thinking. Look at us loading it now. I don't know what you're thinking. Okay, wait. 4, okay, here we go. Go through the 4, after this we're going home. What are the 4 steps? Here, right here. X-intercept, what do I, now tomorrow, I'm not gonna give you one where you gotta cancel the factors, okay? When you get the puka. You're not gonna have that tomorrow. You're gonna have that on the test though. Tomorrow gonna be just like this, no canceling. Okay, I just wanna see if you can do the basic. Like X-intercept, quick. 3. That's boorish. Okay, whatever. Y-intercept. Okay, now this is where some of you have trouble. Plug in 0 for X. What happens when you plug in 0 for X? You get -3 over 0 plus 2 is 2.
Negative? No, not negative. 2 over 3.
What?
3 over 2.
3 over 2.
What did I say?
2 over 3. People, if you cannot plug in 0 for X, I keep saying it, go home, just go home with it. Vertical asymptote. When is the bottom 0? X equal -2, X equal 1.
No.
Horizontal asymptote. Now if you multiply, now you don't, those of you who can see, you don't need to multiply it out, but that would be a plus X minus 2. If the power on the bottom is bigger, then what?
Slant.
No, we're not doing slant asymptotes in this class. It's y equals 0. In algebra 2b, we don't do slant asymptotes. When you get to pre-calculus, we do slant asymptotes. Okay, Mr. Parkman, this side, I don't know. Just look, could be either up there or down there. So there's several things you can do. You can plug in a point, or you want to figure out what's in between here first.
In between.
Okay, in between. Okay, in between. I know the graph gotta pass through this point. There's no x-intercept here, and then the graph gotta follow the asymptote. So what? Yeah, it's gotta be a u going up like this, right? You guys see that? That's the only way the graph can look. How can the thing be u down if there's no y-intercept, right? The graph cannot cross the x-axis. That's why. Oh, so now that I know it's going up like this, then on the opposite side, it's what? Is it up here or down there?
Down there.
It's down there because -2 came from this factor odd power. And that's why it's going to be down there. Or you could have plugged in a point, like I said, you could figure it out. Okay, now what about on the opposite side of this vertical asymptote? This goes up on this side, so on this side going to be what? Up or down?
Down.
How do you know? Because x equal 1 came from this factor, has an odd power, so it's going to go opposite way. If it's up on that side, it's down on this side. Okay, now go through or bounce up?
Through.
How do you know? Because x equal 3 came from this factor, which is an odd power, so it goes through. Now what? As the graph goes out to the right and the left, it's got to get closer to the horizontal asymptote. Okay, anyway, if you forget any of this, like tonight, let's say you go home, you do your homework, tomorrow you get a quiz, just watch the thing. Just watch it. Watch it! Okay, I don't want to, I can't be on camera telling you I'm excusing you 15 minutes early because the administration's going to get mad
So what are you gonna do?
if they watch the video.
So what are you gonna do?
Just tell them, please don't watch the video.
14.
Please.
Are you
Okay, wait, just do it secretly. Okay, go home. No, don't make like you're not walking out. Wait, you see the vision? Wait, I'll block the camera lens and you guys walk out. There. Okay, you guys can finish your homework in the last 15 minutes.
And then everybody's gone.
Oh, you guys are so good today.